Right now we're going to look at the AQA GCSE chemistry relative masses and moles. Now this topic is common across Edexcel as well as OCR, so it is quite useful to know about them, and they also come across in the A level. The entire chapter in A level is dedicated to moles and calculations. Right now, let's begin. So have a look at your periodic table, and I want you to write down the atomic mass uh, for these respective elements and have a go at them. Okay, right. So now this is your classic periodic table, right? And I stated earlier that atomic number and atomic mass, these are two different things. Let's look at the example of magnesium. Now a magnesium here, you've got 12, that is the atomic number. Atomic number tells you the total number of protons and electrons. Okay, so if you got 12 proton, that means you also have 12 electrons. Now the atomic mass or relative atomic mass is the 24.3. okay, that tells you total number of proton as well as neutron. So it's a combination of proton and neutron. Okay, so now let's look at the answers. So yeah, you have these respective numbers or relative atomic masses for sodium, magnesium, boron, chlorine, argon, carbon, iron, and barium. Okay, and notice the unit is in grams divided by mole. Right, there are different ways to write this unit as well, or some people write it as grams mole to the power of -1. Okay, but this is perfectly acceptable answer. So what exactly is atoms, compound, and relative formula mass? We just do a little recap on that. So when atoms join together, for example, to make a compound, the mass of the new substance is equal to the mass of all the individual atoms joined together. So for example, you have a water. It has a symbol of H2O, right? It is a chemical formula of H2O. So this tells us that you got two hydrogen atoms and one oxygen atom combined, right? So the formula is H2O. Now how is that useful in writing the relative molecular mass? So you've got a hydrogen, the relative atomic mass for hydrogen is 1 grams per mole, while oxygen we know is 16 grams per mole, if you have your periodic table handy. So you've got a classic example of potassium hydroxide, for example, right? Now there is two terms that I want you to focus on. Now Mr is usually the symbol written for molecular mass or molar mass, while relative atomic mass is often written as Ar. Okay, so in the exams they often say write down the Ar, or in brackets written as atomic mass of sodium, or write down the Ar of oxygen. Okay, so Mr is referring to molar mass, while Ar is referring to relative atomic mass. Right, so let's look at this example of potassium hydroxide. So you've got a respective numbers or respective relative atomic mass of potassium, the respective relative atomic mass of oxygen and hydrogen. Now I've used this example, so sometimes you have variations. So sometimes you have potassium weighs 39.1, depending on whether they're writing as a significant figures or decimal places, right? So how do I calculate relative molecular mass? So you have to add up all the relative atomic masses of that particular compound. Okay, so you got 39.098 plus 15.99 plus 1.008. okay, if I just round them up, I get the combined value of 56 grams per mole, or written as grams mole to the power of -1. These are both correct, right? If you've been doing A-level chemistry, you will often see it written in both of these formats. Okay, right. So now let's have a little go ourselves, have a go at these. pause the video and we will reveal the answers later on. So you have 5 examples from calcium chloride to sodium bicarbonate. Have a go at these examples and work out the molar mass of these compounds. And if you finish early, if you think this is too easy, have a go at these extension question for yourself. Okay, right. So let's go through the answers. Right now, so let's have a look at these compounds again. Right. So calcium chloride, the respective relative atomic masses are written down. I have repeated 30.5 twice, as chlorine is presented twice in the formula. That gives us a combined value of 111.1. Then you have a methanol, which is 12 plus 3 plus 16 plus 1. Now you see I'm representing them in a certain fashion so that you guys understand the corresponding values with the corresponding elements. Okay, right, but in the following examples you will see that how I am bulking them together. Okay, so you got aluminium trichloride, I have written down as 27, which is the relative atomic mass of aluminium, and 3 chlorine atoms are represented by 35.5 each. That gives us combined value of 133.3, 133.5. For methanol, you get a combined value of 32 grams per mole. Then you have ethanoic acid, that gives us combined value of 60, and you have sodium bicarbonate, where you have a combined value of 84.1. Right, now the extension question, which I suggested earlier, you see you can write down the name, which is glucose. If you guessed it correctly, well done. Now you can see that when you have a long compound, it makes sense to write them in brackets. Okay, so 12 is the relative atomic mass of carbon. How many are there? 6. So I times that with 6 plus. So each time you move from carbon to hydrogen or hydrogen to oxygen, you write them in brackets. Now this is simple way of explaining, but they are very important because you will see many of them losing marks in the exams because they have mixed up these numbers or they have not done the BODMAS correctly. So to prevent those problems, it is better to show a systematic working out. So you get a combined value of 180 grams per mole. Right, now moving on to the next question. So what is mole? How is molar mass or relative formula mass and the mass itself related? Chemists don't really react individual atoms and molecules together, right? The normal unit of measure for weight or for mass is gram. Weight is a mole of force. If you look at individual atoms, and if I were to weigh them, then I'll have to get into really small and minute unit of measure, and there is no way we can really weigh such a small grams listed here. For example, that is a very small gram. Okay, now having a better or slightly scaled unit of measure, which is in this case mole, allows you to calculate relative information regarding molar calculations. So these numbers are incredibly small. So what exactly is 1 mole composed of? So how many grams, or is there any other unit that is equal to mole, right? So that's what we're going to look into. Okay, so 1 mole of substance is its relative atomic mass or relative molecular mass in grams. Okay, 1 mole of carbon has a mass of 12 grams. So how did they exactly calculate 12 grams? How do you know that the carbon has 12 grams? and 1 mole must be equal to 12 grams. So this is where they use something that we call Avogadro's constant. Okay, so Avogadro's constant is a big number, okay, with the value of 6.022 times 10 to the power of 23 atoms. Okay, so in 1 mole of a substance you have this many particles. Okay, now that is equal to the grams of that respective atom. Okay, so in 1 mole I have this many particle and it weighs this much. Okay, so if I say this with carbon, it will be 1 mole of carbon has this many particles and it weighs this much. That is why the relative atomic mass is measured in grams per mole. Okay, that's why you see the unit in grams per mole, right? Same thing with sodium. Okay, 1 mole of sodium has this many particles, which is 6.022 times 10 to the power of 23, and it weighs 23.1 gram. Okay, so in short, we say that this many particles of sodium weighs 23.1, hence sodium's relative atomic mass is 23.1 grams per mole. Okay, moving on. So how many atoms are equal to 1 mole of substance? Again, we know that if I know the moles, all I have to do is times the Avogadro's constant with that number of mole. Okay, so in this case I have 0.2 moles of ammonia. We know that in 1 mole of ammonia I have this many particles. In 0.2 moles of ammonia I must have that many particles. Okay, so it is that simple. Okay, so in the exams they may ask you to calculate, okay, how many particles are there in 0.3 moles of oxygen, for example, or how many particles are there in 0.5 moles of hydrochloric acid. So you apply the same procedure. So now how do we calculate moles? If we measure things in mass and we know the molecular mass or formula mass, how do we calculate the moles? So to calculate moles, we apply this formula called mass in grams divided by relative formula mass, which is MR, equal to, so in this case it's 4 grams divided by 40.1, which is the relative formula mass of NaOH, gives you the answer of 0.09975 mole, right? And it's that simple. If you want to have a mass calculated from moles and the relative formula mass, you times the moles. For example, in this case you have sodium chloride and it has a moles of 0.056. You times 0.056 with the relative formula mass of NaCl, which is 58.6, so which gives you the respective mass in grams, which is 3.28. Right, now let's have some practice ourselves. So let's do some practice ourselves. I have provided 5 examples where you have to work out the moles of the following substance. You can use the formula triangle provided, or you can use the equation given at the top. And the second part of the exercise is where you have to work out the mass of the following substance, and the moles have already been given. So let's go through the answers. Have a go at yourself. Right, so for the first one, you can see it's the 5 grams of CO2. You work out the molar mass of CO2, which is 44. 5 divided by 44 gives you 0.1136 mole. For number 2, you get the answer of 0.0427. For the number 3, you get the answer of 0.0891. And for 4 you get answer of 0.1083, and for 5 you get an answer of 0.0959. and you can see that units can be written as grams / mole, or can be written as grams mole to the power of -1. Now these are both are correct way of writing units. Okay, if you do A-level maths or A-level chemistry, you will notice that sometimes units are written like this in particular. Right. Second part of the activity is working out the mass, so where you times them. The answer for that is 24.2. For number 2, you get an answer of 21.389. For number 3, you get an answer of 69.283. For number 4, you get an answer of 22.08. And for number 5, you get an answer of 15.015. Okay, and if you get all of them correct, well done. Now you officially understand how to work out mass and how to work out moles of a substance. Okay, and you must understand the relative formula mass from this exercise. Okay, thank you for listening. I hope you guys have learned something from that lesson.